In recent videos, we looked at polars and pandas in Python for performing data analysis. In this video, we're going to look at DuckDB. Now, DuckDB is a fast in-process analytical database, as it says here, and in this video, we're going to read in data from a CSV file, and we're going to analyze that using SQL. And that's the key selling point about DuckDB. You can perform all of your analytics and aggregation using SQL itself, rather than having to learn a different method of doing that with a Python package such as polars. So we're going to dive into DuckDB in this video, but before we do, if you want to support the channel, we have a Ko-fi page in the description of the video, and don't forget to give the video a thumbs up and subscribe if you're enjoying this content. So let's get started. Now, as I said, DuckDB is basically a database that is in process, and you can perform SQL queries against data that you're reading in from various different sources. They can be different file types, or they could come from data that's in an S3 bucket, or they can be read in from another database as some examples. Now, if we scroll down here, we're going to look at some of the features of DuckDB. First of all, it's very simple to install and deploy, and it has 0 external dependencies. It's also portable, so it's going to run on Linux, Mac OS, and Windows. And also, DuckDB offers a rich SQL dialect, and it can read and write to and from various different files, such as CSV, Parquet, and JSON. And one of the key selling points here is how fast DuckDB is. It can run analytical queries at blazing speed, and that's thanks to the columnar engine that it has under the hood. And that supports parallel execution, and it can process larger than memory workloads. And by storing data in this columnar format, that can really optimize the efficiency of analytical queries when you're trying to aggregate data and get some insights into that data. And finally, DuckDB is also extensible. So third-party features such as new data types and functions, file formats, and SQL syntax can be added. And finally, it's free and it's an open source database. And if we scroll down, we can see how to install DuckDB on various different environments. So from the command line, you can run commands such as this one. If you're running in a Python environment, you can run a pip install command. It's that easy to install. And you can install from cran if you're using R, using this install.packages function. And also from Java, I think this is Maven, although it's been a while since I used Java. And you can run npm install if you're running from a Node.js environment. Now, I've got a Jupyter notebook open here that I'm going to use in this video. So in order to install DuckDB in a Python environment like this, you can run the pip install DuckDB command in the Anaconda prompt in this case, or if you're using a normal Python environment, you can just run pip install in a virtual environment. Now you can see here that the requirement's already satisfied. I have DuckDB installed, and if we go to the Jupyter notebook and execute this cell, you can see that there is no errors here. It's able to find the package and import it. Now what I'm going to do is go to the documentation for the installation page. And if we go to the Python environment here, you can see a usage example, and I'm going to copy this code here and paste it into the Jupyter notebook just under the import statement. And in fact, we already have that in the pasted code. So what we're going to do here is we're going to connect to DuckDB after we've installed it, and we get back a cursor when we call the connect method. And then the cursor can execute SQL queries against the DuckDB database. So for example, if we select a literal value here of 42 and then call fetch all, we're going to get back that number. So we can simply run duckdb.connect to get back a cursor object, and that cursor is going to allow us to execute queries against the database. Now before we write any more code, I'm going to go to this page of the documentation. As it says, to use DuckDB, you must first create a connection to a database. And there are 2 different types of databases that you can use here. So first of all, if you want persistence, and that's basically where data is going to be saved to disk, then you can create a persistent database, and you do that by setting the path to the database file. For example, you can call that mydatabase.duckdb, and that's done when you create the connection. And the second way to connect is in in-memory mode. And when you connect in that mode, your entire dataset is going to be stored in main memory. So we're going to do that, and it's the most simple way to use DuckDB. So if we go back to the Jupyter notebook, this query that we're executing here, that's going to run in in-memory mode, and that's using an in-memory database that's stored globally inside the Python DuckDB module. Now we want to be able to execute queries that are actually interesting and allow us to get some insights into a dataset. So we're going to use a dataset here from Kaggle of employee data. It's the same one I used in a previous video on polars. And you can download that dataset at the top right of the Kaggle page. If we go to this directory here, I'm going to close that on the right hand side, and you can see we already have an employees.csv file here. I'm going to open that, and you can see the different columns that we have in the CSV data. So for example, employees have a first name, a gender, start date, and so on. We're going to analyze some of the data here, particularly the salary column. And we're going to do some aggregation on what team a particular employee is in. For example, calculating the average salary for each team. And we're going to do all of that using SQL because DuckDB is, after all, a database. And that's the big selling point. SQL is a language that's known not just by data scientists or software engineers, but also by data analysts, data engineers, and so on. So DuckDB should be something that can be used by a variety of people. So we're going to start by importing the employee data from the CSV. So in order to do that, let's go back to Jupyter Notebook. And we're going to use a top-level method in DuckDB. And that's the easiest way to execute SQL queries, and it's the duckdb.sql function. And what we can pass in here is an SQL query. For example, select all from, and I'm going to pass the name of the file here, employees.csv, and we're going to execute that and see what we get back. And I need to terminate the string here. But when we execute that, we're getting back this data. Now, what we get back here is actually called a relation in DuckDB. It's an object type. But the interesting thing to note is how easy it is to read data in from a CSV. We can actually just pass the name of it to the select statement, and it's going to read that data in using all the default values for reading in a CSV in DuckDB. Now you can customize how it's read in. So as well as the SQL function, it has a read_CSV function. And all we need to pass into that is the name of the file. So it's going to be employees.csv. And when we execute that, it's going to give us back the same result because it's using all the defaults, but we can actually pass keyword arguments to the read_CSV function that's going to allow us to customize how this is read in. So let's see an example of that. I'm going to go to the documentation on importing CSVs. So we can see the options here, for example, just a normal select against the CSV file. And what we can also do is pass custom options using read_CSV. So I'm going to scroll down here and we can see the parameters that we can use here. And one of the examples here is the columns keyword argument. That's going to allow you to specify column names and column types that are contained in the CSV file. I'm going to focus on a couple of these and then we're going to move on. So the file name is something you can pass in here. So I'm going to set that to true and we're going to see that it's going to add a new column at the right hand side for the name of the file that's being read in. So you can see that at the right hand side, and that might be useful if you're reading from multiple different sources and you might want to perform some filtering or aggregation based on that source. Now, as well as that, if we go back to the documentation, we have another keyword argument called header. And that's going to specify that the file contains a header line with the names of each column. So what we're going to do is set that to false by going back here. And I'm going to set header to false. And when we read that in, you can see that the column names no longer have those names from the CSV. They've been overwritten by just column 0 up to column 7. And you can see the actual column headers have appeared in the first row for the given data. Now that's going to allow us to show one more keyword argument before we move on. So let's say you wanted to skip some number of rows. What we can do is pass the skip rows keyword argument here, and I'm going to set that to 1. And that's hopefully going to remove this line here from the resulting data. And if we execute that, you can see that now we get the actual data and the headers have been removed. So we can pass keyword arguments if we need to customize the way that the CSV is read in using this read_CSV function. Now I'm going to go back to the original query here, and that was using duckdb.sql. And that's just passing a select statement to the function. Now I mentioned earlier that this is of type relation. So if we look at the type here, we're going to see that it's a DuckDB 𝗫 relation type. And it turns out that we can convert this type to various formats. Now to do that, I'm going to store the variable here result just by calling duckdb.sql. And what we can do in the cell below is demonstrate some of these types. So for example, if we want to convert it to a pandas data frame, we can call the .df function and we get back a pandas data frame. So very easy to go from a DuckDB relation to a pandas data frame. And similarly for polars, we can call the .pl function if we want to get back a polars data frame. Now there's a couple more of these. So the .arrow function will give us back a pi_arrow table, as you can see here. And we also have a .fetch_numpy function. So that's going to convert the data into a numpy array. And finally, you might want to just get these back as Python objects. For example, a list of tuples. So we can call .fetchAll, and that's going to give us back, as you can see, a list. And each element in the list is a tuple that contains the data for each field in a row. And there's one tuple for each row of data in the dataset. So .fetchAll will give us back some Python objects that we can then use in our program. And depending on what you're using, whether it's a polars data frame or a pandas data frame and so on, you can call these methods. Now let's move on to actually writing analytical queries using DuckDB. And as I said earlier, this is where the package shines. It's got that columnar processing engine and it can be very fast and efficient. and it uses SQL, which is a fairly universal language. So we've got this statement here, duckdb.sql, where we're selecting all of the columns from employees.csv. What I'm going to do here is actually create a table, basically registering a table here in the DuckDB database. So we're going to create a table here called employees, and that table is going to be created with the results of calling select all from employees.csv. So the syntax here is to create a table called employees as the result of this query, select all from employees.csv. So I'm going to execute that query, and we don't need to store that in a result object. Once we've done that, we should have registered a table called employees in this DuckDB database. And in the cell below, we can actually query that new database table. So we're going to call duckdb.sql again, and we can select all from employees this time. So instead of referencing the file name, we've read that data into a table, and we can now call select all against the table name. And again, we get back a DuckDB relation object, but we can now start to perform these different queries. For example, I might want to order the employees by their salary. So let's execute that query, and we get back the salaries that are lowest at the start of the table. And at the end of the table, we get back the employees that have the highest salaries. If we want that in reverse order, we can use SQL and use the descending keyword, and that reverses the order and gives us back employees with the highest salary at the top of the table. Now this is all native SQL syntax. Another thing we could do here is get the top 5 employees based on the highest salary by using limit5, and that gives us back the table containing only 5 employees, but it's the 5 that have the highest salary. So we're able to start analysing the data just by using SQL and by using the different keywords available in the SQL standard. Now notice we have a column here called bonus percentage. What I want to do now is try and get the employee that has the highest bonus. So let's start by finding the maximum bonus percentage in this table using the max function in SQL. And the name of the column contains a space, so I'm going to use the quotations to basically encapsulate that column. So we're getting the maximum bonus percentage, and that's from the table employees. When we execute that, we get back this percentage here of 19.944. And what we can do if we want to get the employee with that particular bonus is we can write a nested SQL expression. So I'm going to copy the above expression, and we're going to write a different query here. So we're going to select all, and in fact, let me break this into new lines. So we can use 3 quotation marks here to write a multi-line string in Python. So we're going to select all from employees, and then we're going to write a where clause here, where we're going to look at the bonus percentage field. So again, let's wrap that in quotation marks. And we want to check for the employees that have a bonus percentage that's equal to this nested SQL expression that's going to give us back the maximum. And don't forget to end the multi-line string here. Now when we execute this, we're going to get back the employee who has that bonus percentage, the maximum percentage in the data. And that's this guy called Robert here. So just looking at this statement, we're selecting all from the employees table where the bonus percentage is equal to the maximum bonus, and the maximum is calculated in this expression with a nested select statement. Now we could also have a generated column in this data. So what I'm going to do is I'm going to remove all of this code, and I'm going to paste in a query that I've written here. So it's duckdb.sql again, and we're selecting the salary column and the bonus percentage column. And then we have a column that's calculated here. So it takes the salary and it's going to add this calculation to the base salary. So this calculation here is taking that base salary and it's multiplying it by the bonus percentage. So in effect here, this is basically calculating what's the bonus for this employee based on their salary. And that bonus is then added to the base salary to give the total income. So I think that logic is correct, but if it's not, let me know in the comments. And when we execute this, we're going to get back a table here. We have the base salary on the left-hand side and the bonus percentage in the middle. And then we have the total at the right-hand side here. So for example, at the top row, base salary is around 97,000 and the bonus percentage is basically 7%. So this employee's bonus is 7% of 97,300, and whatever that number is added to the base salary should be 104,066. So what we can do in SQL is not only reference the actual columns in the table, but we can also perform calculations on those columns very easily. Now this is all supported in DuckDB. You can output new columns as easily as adding them to the select statement. And then you have a lot of options for persisting the data to different sources, whether it's files or databases or an S3 bucket and so on. So let's move on to some new queries here using DuckDB. Let's say we want to get the average salary from the table. So the salary column there, we want to get the average across all of the salaries in this column, and that's from the employees table. If we execute that, you can see we get back the number 90,662. So this is an aggregation that returns a scalar value. It's just a single value returned from that. So in order to get that out of the relation and into our code, we could call that function that we saw earlier, 𝗏𝗏, and that's going to give us back a list containing the tuple. But because this is a single value, we have a different function that we can use called fetch1, and that gives us back a tuple rather than the list of tuples. And that tuple contains a single element, so we can index in at element 0 here to get back the number. So that's an example of how we can perform aggregation and get back the aggregated value from the query. I'm going to remove this code here, and let's go back to the select all expression again. In fact, let's just actually select a subset of the columns here. So I'm going to select the team column as well as the salary column, and that gives us back this table here. So we have the team column on the left hand side and the salary on the right hand side here. Now notice that we have multiple teams here. We're not doing any kind of grouping in this statement at the moment, but that's what I want to do now. I want to actually take each employee and I want to group by the team column, and then for each grouping, for each team in the data, we want to calculate the average salary for that team. So we can accomplish this using a group by statement in SQL, and that works perfectly fine with DuckDB as well. So let's add a group by here to this, and we're going to group by the team column. And rather than the salary, we're going to get the average salary by using the average function that's built in here to DuckDB. Now if we execute this, we get back a different data set, and it only contains 11 rows, and that tells us that the team column has 11 distinct values. And for each one of those, we have the average salary appearing on the right hand side. So for example, the HR team has an average salary of 90,944 and so on. Now this is where DuckDB really shines. Obviously this is a pretty simple query really. It's not doing anything too complicated, but when we're performing groupings and aggregating data over different departments like we're doing here, these kind of analytical queries is where DuckDB is going to be really fast, and it's going to use SQL, which comes with all those benefits that we mentioned earlier. Now notice that we have a null team here. In SQL we can remove null values very easily. Before we do that, I'm going to break this out into new lines just so that we can see the query a bit better. So we're grouping by the team column, and we can end that here. Now before we do the group by statement, we can add a where clause here to filter out the teams, or rather to filter out the employees whose team is null. So where team is not null is what we want to add here. So we're selecting the team and the average salary from employees, but only for those employees who have a team. And in order to filter out nulls, we use is not null within the where clause. So let's now execute that, and rather than 11 rows, we now get back 10 rows, and it doesn't have null in the output. And another thing we might want to do with analytical queries like this is order the results. So at the bottom, I'm going to order by the average salary. And when we execute this, we're going to see the lowest to highest salary appear on the aggregated column. So let's execute that, and you can see that here we have client services with the lowest average salary in the data, whereas the engineering department here, the engineering team, that has the highest salary. And like before, we can just use the descending keyword to get that in reverse order from highest to lowest. Now this is all just built into DuckDB, but it uses exactly the same conventions as SQL typically does in other databases like Postgres. So anyone who's familiar with SQL can very quickly start analyzing data using DuckDB. Now I'm going to go back to the original query one more time, and we're going to perform a couple of more queries before we end the video. So if we select all from employees, notice that we have a gender column as well. So we're going to do some grouping based on the gender. So to the query, I'm going to add a group by gender statement here. And again, I want to add that where clause, and we're going to make sure that all the results here contain data. So where gender is not null, and that's again going to filter out any employees who have null in the gender. And then for the selection, I'm going to get back that gender column, as well as the average salary across the gender, and then the max salary as well. And that's going to tell us that for each gender, what is the maximum salary in the data. When we execute that, we get back a table that contains 2 rows. And you can see the average salary for females is 90,000, for males is 91,000, and then we also get a maximum salary of 149,000 for females and 148,000 across the males. So we've taken this data and we've taken the gender column and grouped by that column, excluding any null values, and we're finding the average salary and the maximum salary for each of the genders in the data. Now I want to finish the video just by showing how we can cast from one data type to another, and DuckDB actually follows the PostgreSQL conventions for this. So if you're familiar with Postgres, you'll understand this syntax here. So let's go over it now. I'm going to remove this here and we're going to select all from the employees column. And let's have a look at the columns that we have here. Now we have a salary column and that's an int64 data type. Let's imagine we want to cast that to a floating point number. So we're going to see how to do that just now. So I'm going to go back up to the query here. So what we're going to do is select the salary column from the data. And you can see we get that back in int format. In order to cast it, we can use this syntax here that comes from Postgres, where we have two colons and then the type that we want to cast to. And when we execute that, we get back the data here. And now it's in floating point format. And what we can also do is alias the results. So for example, alias that as salary using the as keyword in SQL. And the results here for the salary are now in floating point number format. What we can also do is we could cast the bonus column. So again, let's go back to the select all expression, and the bonus is currently a double. Let's imagine we wanted to convert that to an integer. What we're going to do at the top here is we're going to select that using the cast function in SQL. And again, this is following the Postgres SQL dialect. We can cast the name of the column that we're providing here, which is bonus percentage, as, and then we provide the data type, And the data type that we're using is integer. So let's execute this query and we get back the bonus percentage as an integer. Now again, we can do some aliasing here. So using the as keyword, we could alias this to just the name bonus and we get back a nicer looking column name here. So when we perform casting, you can alias the results. And in this case, what it's done is it's taken the bonus percentage, which is a float or a double, and it's casted that to an integer, which is basically rounding it to the nearest int. And that's almost all for this video. I just want to mention that DuckDB actually supports the full range of database operations, and that includes support for joining different tables that you have in your database schema. So you can perform all the different joins that you normally would in a database. And DuckDB also has support for constraints, for indexes and built-in functions. It has support for subqueries and case statements and many more. I'll leave a link to the documentation for DuckDB just below the video. And in particular, if you're using this for analytical queries and you have huge amounts of data, then indexes are something that you might want to look into to speed up the queries that you're performing on that data. And the final thing to show here is that we can actually remove tables from the schema just as we normally would in SQL. So I'm going to run a show tables command here, show tables statement in SQL. You can see the tables that we have in the current schema, and that's just the employees table. What I'm going to do just above this is I'm going to run another query here using duckdb.sql, and that's the drop table statement in SQL, and we provide the name of the table we want to drop. In this case, it's employees. When we execute that, after that has executed and it's dropped the table, then the show tables command contains 0 rows. It no longer has an employees table in the DuckDB database. So we can add tables as we did at the start of the video. We can also drop tables, and as well as selecting data, we can insert data not only from files but also from SQL queries using the insert into statement. And we can also update rows in the table and delete rows using those statements in SQL as well. So it's very flexible. Anyone who's familiar with databases is going to find DuckDB very intuitive, and it's very easy to aggregate data and to take the results of aggregations and dump them to different file types or send them to an S3 bucket or an Azure Blob Storage container or whatever you want to do with that data. And I think it's a tool that's got a lot of potential for data engineering. So for example, for moving data from one place to another and maybe transforming that data in between, you don't always need to install something like PySpark or Spark itself. Now, Spark is very good for distributing datasets across machines when you have absolutely massive amounts of data. But often, and I would say maybe 90% of the time at least, DuckDB might be sufficient instead of using Spark, because data often will fit onto a single machine, and you can perform those processing steps and ETL using DuckDB maybe instead of using something like Spark. If you have any opinions about that, let me know in the comments. This has just been an intro video, but I'd like to dive into potential use cases in the future. Thanks very much for watching. If you've enjoyed the video, give it a thumbs up. And if you want to support the channel, we have a Ko-fi page in the description. And don't forget to subscribe if you've not already done so. Thanks again, and we'll see you in the next video.